Yo, 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 this is Teacher Keith here with Justin, the little scientist. Say hi, Justin. Look at my
Hello.
hair. My hair is like totally scientist. I've got crazy hair over here. We are here with pulley simulation. We've got a FET. This is a PHET. Yo, a PHET is like a simulation of real life, but we can control everything because it's a controlled environment. So my man Justin here has two hypotheses that we are hypotheses that we are
Mm,
going to test out. The number one hypothesis is about the amount of pulleys. Justin, hit us. What is your hypothesis?
if the amount of police increases, then the amount of applied force, uh, the unit Newton needed will decrease.
That's right. If the amount of pulleys increase, then the amount of force needed will decrease. I think my man Justin is onto something. Let's check it out on the FET, on the pulley simulation. I apologize. It's a very small simulation. I can't blow it up. Maybe I can. I'll try it. No, it doesn't let me make it bigger. So this is what we've got going on, guys. So what do you think? What is your hypothesis for our viewers at home? Tell us what you think. The amount of pulleys, will it make work harder or will it make work easier? So
It
over
can,
here,
it
over
can,
I cannot zoom in. Can I?
oh, I can.
You can? How did
Yeah.
you zoom in?
Just press there's a command plus.
Oh, here, I'm going to stop sharing. My man Justin's going to share his simulation because it's bigger. Go. Justin, stop share. Look at my hair. I have a hypothesis. Is the amount of hair, the mass of hair, does that require the amount of gel needed in order to make it fight gravity and go up in the air like my hair is? It looks silly.
like Einstein.
Like Einstein. Crazy. Oh, Justin, snap. He's got it figured out. Here we go. Justin, 用大一点. 用大一点. So
Okay.
Justin's got it all ready to go. Whoa, Justin, you're blowing my mind. Oh, no, we got to see all of the boxes, sir. That's a little too big. Here we go. Perfect. Okay, that's perfect. That's perfect. This is good for our home viewing audience. Are you ready? Sir,
Yeah.
let's see how much force is needed just right now with a single fixed pulley system. So keep it on single fixed. Now let's
Uh,
pull it up. Use the applied force on the bottom. Let's increase the load. Justin, let's increase the load too. Let's go all the way, really heavy.
10 units.
Oh, wow. Did you just see that? Wow, that was so cool. What happened when he did increase the load? Check this out, guys. Go. No,
E-
no, 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 no. Justin, do it again. Increase the load, decrease the load.
uh,
Wow. Wow. Up again. Wow. Oh, the box got bigger. Look at that load size getting bigger. Wow. Awesome. Let's keep it the most. We're going to
uh,
give Justin a little bit of a workout on his arms today. Let's do distance to lift all the way.
uh,
There we go. Distance to lift. Big. That's a big one. Friction. Let's not touch any of the friction or pulley diameter yet because that's not what we're testing. We're going to keep it the same. As long as we keep those, what are those called? Starts with a V, Justin? Load
variable.
variables. We got to keep those variables the same and consistent because we're only testing one independent variable, which is what?
Uh, what's that? No,
Amount.
amount of force.
Nope. Independent variable is amount of pulleys. The dependent variable is the amount of force. Let's see. Okay. Ready?
Uh-huh. Applied force.
Yeah. Distance pulled 0.2 meters, and he was doing it at 10 newtons. So we have to remember because it's got to be the same applied. So to pull 2 meters, 0.2 meters, he needed 10 newtons of force. Let's try single movable.
Single move.
Whoa, this is cool. Let's check this out. Now, only 10 newtons. Let's see what happens.
Oh,
That's 5 newtons. That's as far as it'll let you go up?
Yeah.
Oh, cool. So, Justin, already we can make a conclusion based on this simulation that single fixed required how many newtons?
10.
Good. And a single movable required how many newtons?
5 newtons.
5 newtons. So that's interesting. Already we're seeing that it's getting easier, right? Work is getting easier. All right, let's check out single compound. I wonder what this is going to look like.
Oh.
Whoa, single compound is a pulley attached to the load and a pulley above the load. So this is cool. This is cool. Let's do it. I think it's going to be a lot less.
Still 5.
Still 5. Can you make an idea about why it's still 5, Justin? Think about the forces that are involved. I'm just guessing. I don't know. We're increasing one force. The amount of
pulley.
Okay, the amount of friction, I think there's more friction involved here. That's why it's the same, but I'm not sure. This is interesting.
The friction is 0.
The friction is 0. I know. Why is that doing it then? Why is it 5? Okay, let's see double compound. Is his hypothesis right? Moment of truth. Here we go. Moment of truth. Will the force be less? A more amount of pulleys? And whoa, Justin, when you added the pulley, you look at how many newtons it took now.
That's 2.5.
Which is what?
Newton.
Half of
the effort you need.
2.5 newtons. Yes, you got it. It reduced the effort by half, right? Because how many is a single compound again?
5.
5. So this adding a doubling the pulleys added reduced the effort by half, correct?
Correct.
So that's kind of cool. Are you making notes on this right now?
No.
Are you making notes?
No.
No? Okay, let's try. Now, Justin, whoa. Before we try triple compound, tell me what is your estimate for how many newtons if we add one more pulley?
Can I calculate?
Sure. He's going to calculate. Boys and girls, he's a mathematician. He's going to calculate. He's using a calculator.
Paper.
Oh, he's using a paper. Here we go. Okay, you know what? Let's, Justin, let's do this. Do your calculation for me. Come here. Do your calculation for me here. Do your calculation for me on the whiteboard so we can show our friends at home.
Oh, okay.
Okay, let's do it. I'll give you remote control. Okay, show us on the whiteboard how he calculates this. Let's see.
Just estimate.
He's using the long division, folks.
Like that?
Sorry, Justin, are you saying 16.3 newtons? Or 1.63?
1.63, sorry.
Okay, the decimal was in the wrong place. Okay, so 1.63 newtons. I'm going to guess, he's close. I'm going to guess it's 1.88 newtons. Let's see who's the winner. Here we go. Student or master? Who will be who? Let's see. Let's go back. Okay, I'm going to stop share. How many newtons is it? Share your screen. Okay. Triple compound. Got to change it. Whoa, look at those pulleys. Let's pull it up. And Oh, Justin wins 1.66 newtons. He's mathematician, amazing. So cool. Here we go. 1.66 newtons, and Justin wins. He 1.66666666, right?
Uh-huh.
That's amazing, Justin. You just figured that out mathematically. Congratulations. You beat the master. Here we go. Next one. Let's do quadruple compound. Justin, wait. What's your calculation for this one?
Oh,
no. You got to use the whiteboard. If you're going to do any math, we want to see it. We want to see the math.
same math as before.
So do the same math as before. Show me.
I need remote control.
Huh?
I need remote control.
Oh, remote control. Sorry. Okay, you're good. Justin says 1.222. No, 1.28. 1.25. 1.25. Okay, I'm gonna guess. Oh, sorry. Is this your guess? 1.25? Okay. So Justin says 1.25. I'm gonna go lower. I'm gonna go with, and this is newtons, right? I'm gonna say 1.15 newtons is the answer. And I'm just estimating. Justin calculated. I'm just estimating who is right, teacher or master or student. Justin says 1.25. I say 1.15. Who is right? Ready? Stop, share. Justin, share the FET. Look at my hair. Focus on the hair, everyone. Here we go. And here we go. Oh, Justin beat me again. 1.25 newtons. All right. Amazing. Look at that. To get the same. So, Justin, we now have a conclusion. Is our hypothesis, tell the audience at home. Tell the audience at home. Okay, stop share, just so your face is big. Tell the audience at home what your conclusion is based on the hypothesis of amount of pulleys and force needed. Use your hypothesis to tell us what is true. What have we just learned?
We just learned that as the amount of pulleys increases, then the amount of effort that I needed to use will decrease.
You got it. The amount of effort needed to move it the same distance. Our controlled variables are distance and what else? What are controlled variables?
Distance and what?
Distance and what? Think about the load.
Friction.
No. Well, friction is the same. You're right. That could be a control variable too because we didn't change the friction. But think about the load. What happened when you made the load, mass of the load, bigger, smaller? Right? So does the load change? No, the load did not change. Right? It's a control variable. We didn't change the load either. So I just want to make sure you understand what your control variables. So control variables are, again, our distance and the mass of the load, right? And again, amount of friction. That's a good point. So we have those three. And teacher K's hair. That's a control variable, right? We got it. All right, let's try our next experiment. Thanks for watching.
Bye-bye.